Alright, we're going to do the first video of 7.2. Now we're going to add another rule in, and it's going to be when we're dividing like bases. You can see I already have written here, this is the main concept. When you divide like bases, you want to subtract the exponents. And one thing you always hear me say, you want to keep the base and the exponent wherever the exponent is bigger. So if I look at these two examples, 2 to the 4th over 2 to the 1st, well, I know if I subtract the 4 and the 1, if I subtract the 4 and the 1, I get 3, but it's going to be 2 to the 3rd is up top, and it's over 1. For the next one, it's going to reverse. I'm still going to do 4 minus 1, but since this exponent here is bigger in the bottom, I'm going to get 2 to the 3rd in the bottom. The top, this 2 is going to go away, and it's going to be 1. Okay, so whenever dividing like bases, you want to subtract the exponents. We're not going to deal with negative exponents yet. That'll probably be in the next couple videos. But just keep the exponent for the base where the exponent originally is bigger. Okay, so if I actually did the math for this, you can see I have x. I have the same base x. It's just x raised to the m minus n. Just another way of saying just subtract the exponents. Okay, I'm going to go over some of the next couple in this section. Number one, if we look at this, our base is y for each. So if I just do 7 minus 2, I get 5. Now the exponent's bigger here in the top, so it's going to be y to the 5th is up top over 1. Now y to the 5th over 1 is the same as saying y to the 5th. So that's our answer. Now number 2, I reverse it. Remember, this is called reciprocal. I'm still going to do 7 minus 2, except here the exponent's bigger in the bottom. So that means y to the 5th is going to be in the denominator. It's going to be in the bottom. The top is just going to be 1. So it's 1 over y to the 5th. Okay, so I'm not going to deal with any exponents. Okay, if I look at number 3, now I have two variables. And I have two like bases, x's and y's. If I first look at the x's, well, let's see here. For the x's, I have this 2 and this 3. It's bigger up top. So I'm going to have x up top. And if I subtract, this 3 minus this 2 is 1, so it's x to the 1st. So I'm done with the x's. Now the y's, it's bigger up top. The y in the bottom is just like saying y to the 1st. So 4 minus this 1 gives me 3, and that y cubed is up top. And everything in the bottom pretty much goes away, so it's like saying it's over 1. Well, if you divide by 1, this is the same as saying x y cubed. Okay, number 4, now I have three variables. I have k, m, and p. So if I look at k right here, I have k to the 7th over k to the 5th. The exponent's bigger up top, so the k is going to stay up top. And if I do 7 minus this 5, it gives me 2. So I'm done with the k's. I'll just cross them out. Let's go to the m's. So m is bigger up top, and 10 minus 3 is 7, so it's m to the 7th. So now I'm done with the m's. And then if I look at the p's, the p is bigger in the bottom now. Bottom is 3, top is just p to the 1st. So the p is going to be in the bottom, and 3 minus this 1 gives me 2. So it's p squared. Okay, and that's it right there. That's our answer. Okay, now the next couple, 5, 6, and 7, you can see now I put numbers in. This is where we really struggled when we did multiplication. We focused so much on just working with the exponents for the variables that we forgot we actually have numbers here. Okay, the actual coefficients here are 3 over 6. Let's deal with that first. 3 over 6, that will reduce to 1/2. So I'm first just going to put 1 over 2. So I simplified 3 and 6. Then we'll do the same thing I did. X's, well, let's see here, x cubed is more than x to the 1st. So you're going to get x squared up top. Done with the x's. The y's are bigger in the bottom. 7 is bigger than the 5, so I'm going to get y in the bottom, and 7 minus this 5 gives me 2. So I'm done with the y's. Oops. And then z's bigger in the bottom. So I'm going to have z in the bottom. 10 minus this 7 gives me 3, so I get z cubed in the bottom. And then that's it. That's our answer right there. Okay, we'll just do one more. Let's do number 6. Okay, first, if I look at 15 and 12, 3 goes, common factor is 3. 3 goes into 15 5 times. 3 goes into 12 4 times. So 15 over 12 reduces to 5/4. I'm done with that. Okay, then if I look, I have a. There's no a in the bottom, so that just stays as a. So I'm done with that. Okay, let's look at the b. I have b to the fifth over b to the first. They're not all lined up here. So this b is going to stay up top, and 5 minus this 1 is 4, so it's b to the fourth up top. So let's get rid of the b's. Okay, I have c over this c to the fourth. C is bigger in the bottom, so I'm going to have c. This is like saying c to the first. So 4 minus this 1 gives me 3, so it's c cubed. So I'm done with c's. Then all I have is the x's. I have x to the fourth over x to the first. X is bigger up top, so I have x up top. And this 4 minus this 1 gives me 3. So that took a little bit more work there. All right, but nowhere in here do I have negative exponents. The biggest thing is keep the base and the exponent wherever the exponent is bigger originally in the problem.